Hi, everyone. Thank you for joining us today for the third webinar in our series of BioCord-based webinars. So today I will be speaking about how to make the most out of your BioCord pilot project, but a lot of the information that I'm presenting today will cover best practices that are applicable to all piloting in general. So I'll go into some details about pilot project considerations, such as how to determine what you should be monitoring for and how frequently, or how to ensure your pilot project is scalable to handle full plant loads. And I'm also going to be talking about our own plug-and-play BioCord pilot unit for on-site testing. This is the third webinar in a series that Bishop Water will be hosting over the next couple of weeks. These BioCord-based webinars will explore current topics in wastewater treatment. So last week we spoke about how you can maximize cold weather removals using BioCord. This week, like I said, we're talking about piloting and getting the biggest bang for your buck when it comes to BioCord pilot projects. And next week, we'll be focusing on talking about strategies to optimize the design of your BioCord system, as well as to validate its performance using modeling software. So for outlines of these topics and to see a schedule of our webinars, you can just look us up or follow us on Twitter or LinkedIn, or go to the Bishop Water Technologies website. There will be a link to the webinars on the homepage there. You can also get all the information there. Oh, and you can also find the link to register for the webinars, which will be occurring Thursdays at 2 p.m. EST. So these webinars will be presented by me, Christine Gann, as well as my colleague, Roberta Meffatone. We're both wastewater and engineering specialists here at Bishop, and we can be contacted via email if you have any questions about the content of these webinars or about any of these topics in general. And this is actually the last webinar I'll be hosting. Roberta will be taking over for the next two webinars on optimization on process control. They're going to be really informative and interesting. So if you've never considered using wastewater modeling programs or process control methods to maximize your treatment efficiencies, I highly encourage you to register, as you may be surprised at how easy it is to do and how much process information it can actually provide. So again, let me start off by introducing our keystone technology for those who aren't already familiar with it. The BioCord Reactor is a bioreactor developed by us, Bishop Water Technologies. It provides wastewater treating bacteria with the optimal conditions for growth and proliferation to allow for high levels of treatment activity. So this includes the provision of a string-like media that has a high surface area and a charge for the microbes to attach and hold onto, as well as a unique low-energy aeration system with an enhanced oxygen transfer capabilities to supply lots of oxygen directly to these microbes. So as seen in the diagram to the right here, providing these things and these optimal conditions for the microbes leads to the formation of a robust biofilm, which is essentially a consortium of microorganisms that stick to a surface as well as to each other in really high numbers, allowing for higher contaminant removals and more efficient wastewater treatment. So BioCord reactors can be used in municipal, industrial, and agricultural applications to enhance the removals of BOD, COD, TSS, and nitrogen. It is a modular and customizable technology that is designed specifically for each individual application. So as you can see, it can be installed in situ within a lagoon or basin. It can be used to enhance or improve treatment reductions and increase the capacity of an existing facility, or it can also be used or designed as a standalone or a side stream treatment if required. I did cover some of the performance advantages of BioCord in previous webinars, so I won't spend too much time reiterating these points, but I have included them in the slides for this presentation, which will be distributed at the end of this webinar. So you can go ahead and go through them at a later time if you wish. But to quickly summarize, some performance advantages would include, of course, significantly increased BOD and ammonia removals to meet even the most stringent discharge limits, an increase of wastewater treating biomass to minimize washout, enhanced oxygen delivery and mixing to optimize performance, as well as demonstrated treatment performance in cold weather conditions. In addition to the performance advantages, there are also a number of operational or facility-specific advantages associated with a BioCord reactor system, including low CAPEX and OPEX costs, a low energy, maintenance, and footprint requirement. BioCord reactor systems are modular and customizable. And as well, Bishop offers continued support to all of our clients during startup and operation of any project. So Bishop Water does offer a prefabricated plug-and-play BioCord pilot system. And I'll start off by talking about this unit and how it works, its operation, and some advantages to piloting with Bishop. This is a great unit that contains everything you need to test out a BioCord reactor system within a single shipping container, including the reactors themselves, an intake pump, sample ports, and a control panel for flow control. So it can be shipped to site, and with just a few connections, it's pretty much ready to receive flow. This unit is great for facilities that want to easily test BioCord at their site and validate its performance or how well it can treat a waste stream. Like I said, this system is extremely easy to set up. It can be installed and fully operational in just 1 day or less. The standard unit comes with 4 tanks and 4 aerated BioCord reactors, as you can see in this photo here, as well as in this PNID on the right. And the operation of these 4 tanks can vary depending on what your treatment targets are, as well as what your full-scale flows will be. So the intake pump skid is VFD controlled to ensure that we're aware of what's coming into our system and to ensure that we can properly monitor performance. Right now, our default pump is sent to a max flow of 32 cubic meters a day, but this pump can be changed out to be bigger or smaller depending on what our target treatment volumes are. And I would typically recommend starting with a more conservative flow, and then you can ramp it up later on and max out that flow rate to see how our system performs at even higher contaminant loads. Although our pilot system is plug and play, we still design its operation to be very site specific. And we can switch out some components pretty easily to customize it to whatever site that it's going to. So this is just an example of one of the spreadsheets that we use to make sure that our system is going to perform well. For example, we can set what the anticipated influent characteristics are, so what the ammonia and BOD concentrations would be, as well as what the pilot flow rate should be based on scale factors and what the full scale flows are going to be. And then from there, we can see if we've got enough oxygen into our system or if our nitrification and BOD rates are sufficient, or maybe we just need to adjust the sizing of our BioCord units to ensure that we're meeting the targets for treatment. So every facility is different and will have different needs. So it is important to look at all of these things first before just shipping off a unit to be tested. And when piloting with Bishop, we always ensure that we're doing this and looking at all the different design factors first. Our pilot system is designed for a low energy demand and can be used in remote or off-grid locations, as can be seen from this cold weather pilot here that was powered at a remote site using a diesel generator. So with our standard operation, the energy demand for a month of usage would only be about 2,900 kilowatts, and that would be dedicated to running the 4 3/4 horsepower compressors as well as the influent pump. These are pretty standard operation and would require a typical electrical hookup. It's also relatively easy to operate, requiring minimal oversight except for sample collection, some visual maintenance checks, and the occasional flow rate or aeration adjustment based on its performance. So if you are interested in piloting a BioCord reactor system, we do have some PDF brochures available that we'll be sending out to all the attendees along with the slides from this presentation. And I should also mention that these units are available for purchase as a permanent treatment system. So if your facility is rather small, or depending on what the size of your facility is and the full scale flow rates, our containerized BioCord system can actually act as a permanent side stream process to help meet your treatment target goals. If things change and then treatment needs to be improved even further on, the system is modular, so more BioCord containerized systems can be added as needed. Bishop also offers other options for piloting if that is the desire. For instance, we can fabricate our pilot units to be retrofit into a tanker basin that may already be sitting on site and that maybe the client wants to use for piloting instead of getting a plug and play unit, in which case we could just specify the flow rates and the operational conditions required to treat the wastewater. We can also fabricate pilot systems to treat a specified volume of wastewater per day, for example, a specific percentage of your full plant flows. Or there's also the possibility of conducting a full-scale pilot where we would actually install the reactors directly into a lagoon or a treatment basin. Although this option is typically a bit more complex and would require a bit more investment since you'll likely need more reactors to treat the full flow. All right, so there are many advantages to piloting with Bishop, or piloting in general, but these are specific to Bishop. And if you're considering an upgrade and have the means to do a pilot project, I would highly encourage you to do so, not only because it can help to validate the performance of a process or technology such as BioCord, but for other reasons that will be beneficial to you in the long term as well. So, for example, collecting site specific data can provide a lot of insight into your existing treatment process and indicate to you a number of useful things, such as where the best place to focus treatment is. So, having a comprehensive data set is also really useful for plant optimization. And so, collecting this data in tandem with doing your pilot is kind of a great way to kill two birds with one stone. Piloting also helps to refine a full-scale BioCord design by fully characterizing the wastewater at your site to see what kind of variations in flow or contaminant concentrations that the plant experiences on a day-to-day basis. And that really helps us to refine our design to make sure that we're accounting for these fluctuations, which can at times sometimes be quite dramatic. And so that leads us to our next point, which is that piloting can lead to long-term cost savings. So sometimes refinement of a full-scale design also means making it smaller. Maybe the initial data that we received was really conservative, or we find that less BioCord reactors are actually required than we originally anticipated. So that's also a big benefit of piloting. Sometimes your capital costs can end up decreasing. And the beauty of BioCord reactors is that they're modular. So if you do need more capacity later on, it can be easily added in a stepwise manner as your rates increase or your flow rates increase, or if you just need more treatment in general. Piloting can also help to identify other solutions that could work in tandem with BioCord or even on its own that maybe you may have missed if it had not been for piloting. And these solutions may sometimes be even more simple and more cost effective and can ultimately end up saving more money in the long run. And I do have a great example of this later on, so I will come back to that point. I also want to mention another benefit of piloting with Bishop, which is that we offer a credit from piloting to go towards full-scale costs, sometimes even up to 100% of the piloting costs, depending on the site. So ultimately, if you know your facility could use an upgrade or an increase in capacity, finding a pilot program that offers this kind of incentive like we do can be really beneficial because you're basically piloting for free and also getting all this really great useful data out of it. Of course, piloting also does have its challenges. It does require a time commitment, especially because in general, longer pilots are a bit more beneficial because it allows the BioCord system to fully reach steady state and also allows for observation of performance through different environmental conditions. Piloting does also require some operational oversight for wastewater sampling and analysis, as well as for maintenance of the system. Luckily, Bishop has designed our BioCord pilot unit to be as low maintenance as possible, just as our full-scale systems are. So typically for us, it's just a matter of ensuring that the pilot system is still receiving power and visual checks of the pumps and compressors to ensure that they're operating as intended. Lastly, since you are going to be collecting a lot of data, you will also have to interpret it fully to measure its performance. And that means interpretation of the data that was collected before, during, and any data that may have been collected post-piloting. And there are actually a lot of different performance factors to consider that can help you better understand your system and tell you how you can maintain maximum performance. Luckily, if you conduct a BioCord pilot project, we will do all that work for you. So once your pilot is over and all the data have been collected and logged, Bishop Water puts together a comprehensive report that outlines all of the variables, what they mean, how they changed over time, and how they all impacted BioCord, which is really great because sometimes having a big data set like this can be pretty daunting, and some people don't really know where to start. As well, we also provide recommendations for full-scale operation and a full-scale BioCord design based on all these factors, which also includes scalability factors for considering the transition to a full-scale system. So essentially, we're letting the data tell a story, not only about the BioCord pilot system and how it performed, but also about your specific facility and the characterization of your wastewater. And that can be also extremely helpful in the future for plant troubleshooting or any future upgrades that you want to implement. So some other considerations that you may want to think about before beginning a pilot. Number one is what your budget is. Of course, you need to have the resources to allocate to the actual rental or installation costs of a pilot system. But other than that, you also have to consider how much manpower you can devote to operational oversight, as well as how frequently you can collect samples and have them analyzed. If you know how much you can spend, this is really helpful for us to know because it allows us to design a pilot project and sampling program that's going to provide you with the most useful data and can also demonstrate performance, but be within that budget. Also, when you're thinking about your budget, I suggest that you also look into some government funding programs that can help to offset some of these piloting costs. An example of this would be the Federation of Canadian Municipalities Green Municipal Fund, or the FCM Fund, which provides capital for both pilot and full-scale projects related to sustainability. In addition, provinces also periodically offer infrastructure funding. And we do have some information on these programs and would be happy to discuss how to apply them to a BioCord pilot project. So if you're interested in that, please shoot me an email and we can go from there. Another consideration is your timeline or how long you want your pilot to run. This also goes hand in hand with the budget consideration. But during the but the duration of your pilot also depends on how soon you're planning or needing to go to full scale. And keep in mind, as I mentioned, in general, longer pilots are more beneficial because it just allows you to see consistency through different environmental conditions and over a longer period of time. So, if you know a facility upgrade will be required in the foreseeable future, I would suggest looking into implementing a pilot program sooner rather than later, so that you are prepared and not rushing a pilot when it happens. And when you rush a pilot, that can sometimes lead to like insufficient data or data that's not that great. So we try to avoid that if we can. And we will also work with you. If you contact us and are interested in a pilot project, we can discuss things like budget and timeline with you to kind of figure out what the best duration for your pilot would be. Finally, it's also really important to define what the objectives of your pilot project are. I know that that seems kind of obvious, but it is so we can ensure that the program that we're designing for you will show that these specific objectives are met. So yeah, like I said, be specific about what you're looking for, whether it's an effluent target or a percent reduction that you're looking to meet, so that we can determine whether the outcome of the pilot is going to help you move forward with a full-scale installation or not. So I'll go into a bit more detail about this now. Typically, there are two main objectives or purposes for conducting a pilot. The first would be to demonstrate treatment performance of the technology in question. So to validate that you can consistently hit those effluent treatment targets by maintaining really high contaminant reductions. And to generate a beautiful looking graph like this, where you have high ammonia influent and low ammonia in the effluent, or whatever your target for treatment is, and you're getting these over 90% removals pretty consistently. So this is what everyone immediately thinks of when they think of what kind of objectives they want to see met from their pilot. And for sure, this can be done, but you need sufficient data regarding what your wastewater characteristics are throughout your process and throughout different seasons so that we know how to size, operate, and locate the pilot. So your data set will dictate how we run the pilot system. And a full historical data set would include things like the influent and effluent concentrations of BOD, COD, ammonia, TSS, or any other relevant contaminants. We'd like to know flow rates, so full-scale plant flow rates, as well as peak flows and loads, any kind of fluctuations that you would see, that sort of thing. And if you don't have a historical data set, which to be fair, most plants don't because it's not typically required in their permit, then the purpose of your pilot would be to determine the optimal design for a full-scale system based on the data set that you collected during piloting. And that includes plant data as well as BioCord treatment performance data. So in this case, we can still demonstrate what the removals are with a pilot BioCord unit, but we're doing so taking into consideration the difference between what the contaminant loads our pilot system was designed to treat versus the contaminant loads that were actually seen during piloting. So sometimes they're the same and your graph will look like this, but typically you should expect to see some kind of variance in your effluent. We then use these results to refine our full-scale BioCord design and sizing to ensure that we're always going to meet our effluent targets. Also, as the pilot goes on and we collect more and more plant data, we can adjust the pilot system operation as we go to achieve more consistent effluent numbers based on that data. So by the end of the pilot, we will be seeing those low effluent numbers that are consistently below targets. And that usually requires an extension of the pilot to be longer in duration so that we can first collect all the data that we need and then adjust the pilot operation to meet those targets. So this is the real life example of the curve from the previous slide, which illustrates nicely how we were able to meet the objective of this pilot project using our plug and play system. So the objective here was to demonstrate that BioCord could significantly improve ammonia reductions from the influent in cold weather conditions. And the pilot project was set up to be able to treat the design, BOD, and ammonia influent concentrations of 75 ppm and 15 ppm respectively. This was based off of a rather limited data set provided to us by the client. And as you can see from the influent data that we actually collected during piloting, which is shown in the red curve here and here, the actual influent concentrations of contaminants were much higher. So for BOD, the influent averaged around 166 ppm, sometimes reaching over 300 ppm in the second half of the pilot project. And that is a pretty significant increase, especially when you consider the fact that BOD hugely influences how much ammonia removals you can get. And for ammonia, the influent averaged 24 ppm compared to the design influent of 15 ppm. So when you look at the table results from these graphs, we can see that even though the actual influent concentrations of BOD and ammonia were much higher than we designed for, we were still able to achieve an average ammonia reduction of 18 milligrams per liter from the influent ammonia coming in. And that meets what our design objective was, which was to reduce 15 ppm of ammonia from the influent. So now, after collecting all this pilot data, we were able to rework our BioCord design to account for the higher BOD and ammonia numbers that we saw during piloting and be confident that the full scale design would be able to accommodate these fluctuations. So all in all, we did consider this pilot project a success, but if you are only looking at effluent numbers and not considering anything else as part of your objective, you could pretty easily misinterpret the graphs on the previous slide to think that, oh, the pilot was maybe not as successful as we'd like because we weren't consistently getting under 5 ppm of ammonia in the effluent every time, even though overall we were still reducing more than the ammonia concentrations that we were designing for. Sometimes clients do have other specific objectives that they would like to see during the pilot. And as I said, we can design a pilot program to be able to accommodate and demonstrate these targets as long as they're discussed and identified upfront, which is another reason why you should be specific with your objectives. So some examples would be verification of cold weather performance, meeting specific effluent targets like passing the LC50 fish toxicity test. We can also design pilots to optimize energy usage. So looking specifically at ways we can decrease energy while maintaining treatment performance. Another objective could also be to determine what other requirements are needed for optimal technology performance. So that one would be most applicable for atypical waters such as mine effluents or breweries where you may need to supplement alkalinity or another kind of nutrient in conjunction with the BioCord to get your optimal contaminant reductions. So this slide shows the details of what information is required to make certain piloting design decisions. You would need to consider things like the location of installation or the CCAN placement, which dictates the type of wastewater from your process flow that you're actually going to be treating. We also need to think about how many BioCord reactors we want to be utilizing in the pilot, as well as what the flow rate's going to be, or what kind of volumes the system is going to be treating per day. What kind of airflow or aeration that we need is also important because we need to be able to meet the oxygen demand of the BOD and ammonia that's coming into the pilot system. And lastly, we should also consider any other areas of concern that may affect BioCord so that we can address them upfront in our pilot program and ensure that it's a success. So on the right here, I've listed the information that we need to make these design decisions. And like I said, when we start, we might not have all of this information right off the bat, but we can collect it during piloting and then change as we go, as I mentioned. So all in all, before starting a pilot, we should try to gather as much data as possible. This is especially important if your determinant of a successful pilot is that the technology's effluent always has like X amount of under X amount of ammonia or BOD. In that case, you basically need to treat your pilot as if you're designing for a full-scale system, because to ensure its scalability to full scale, you need that comprehensive data set, period. And then if you don't have that data available, it's important to understand how to interpret the results to show that we can scale the pilot system to a full scale design to meet your objectives. And again, Bishop always provides a full report at the end of each pilot project to clearly show this to the client. And we always like to have follow-ups as well to address any questions or concerns about the report or to clarify anything about the data or the information that was collected. Okay, so while we're talking about optimizing and designing your pilot project, I want to go into a bit more detail on installation location and emphasize the importance of profiling through your treatment process, because I think sometimes people overlook how important this step can be. Profiling your process or sampling in between each treatment step can help you identify exactly where you need to focus your treatment or where you would want to locate your technology. And it can help save you significant costs in the long run. So I'm going to use this real world example to help illustrate this. This lagoon facility in question had trouble with ammonia removals, especially in the wintertime, and recruited Bishop to conduct a pilot to see if BioCord could help improve these ammonia reductions. So the facility used 3 cells in series for treatment, and the client had actually already made some upgrades to the third aerated cell to try and improve their ammonia removals. These upgrades included building a berm, a center berm to increase the HRT, as well as the installation of a solar B mixing unit and an additional 62 aerators to increase the mixing and oxygen within cell 3. And the data that they provided us is shown here on either side. As you can see, their raw ammonia numbers were about 40 to 50 milligrams per liter, with their effluent ammonia numbers being around 25 to 30 milligrams per liter in the winter and 6 to 9 milligrams per liter in the summer. So not great for the scale of the upgrades that were implemented. And other than that, they also had influent effluent data for BOD, TSS, DO, and pH. And these values were nothing out of the ordinary, kind of standard reductions and ranges based on lagoon wastewater. So looking at this, you could easily just put a BioCord system at the back end here and use it to help reduce this back end 25 to 30 milligrams per liter of ammonia. But when I asked, they also didn't have any interlagoon data. So we suggested that they collect some samples from the effluent of Pond 1 and Pond 2, just to get the full story of what was actually happening. And what they found was that the capacities of Pond 1 and Pond 2 were very limited. They basically were not contributing anything to treatment. And in fact, BOD numbers were actually increasing from the raw influent. So as I mentioned before, and as I spoke about in last week's webinar, BOD has a really big impact on nitrification. And if there's too much, you will have limited nitrification. So even with all their upgrades to cell 3, they weren't getting any better ammonia removals because all the capacity of this cell was just going towards treating this high BOD number coming in from pond 2's effluent. So in this case, they would have almost been better off putting the raw influent directly into cell 3 rather than operating the cells like this. So looking at this data, our thoughts were immediately that they probably need to dredge their lagoons. If your lagoons haven't been cleaned out in a while and enough sludge builds up at the bottom, you can actually get something called benthal feedback, which is when the bacteria in your sludge layer start breaking down all those contaminants and organics in the sludge, and it can re-release organics and nutrients back into the water column. So I asked our clients when the last time they had dredged out their cells, and the answer was never. So at this point, we were pretty certain that even just doing a lagoon cleanout would significantly help them to improve their plant performance, because you'd be getting back some of that capacity that has been lost in these two cells. So all in all, we still conducted this pilot because the reductions still needed to be improved, but making the assumptions based on the fact that they would be cleaning out ponds 1 and 2, and that the capacity of these cells would be at least somewhat restored to be able to minimize the TSS and at least some BOD that would be going into pond 3. So with these assumptions, it was determined that the best location of a BioCord installation would be pond 2, because this would allow for as much front-end BOD and ammonia removal as possible to optimize the wastewater prior to entering cell 3. So that means that the previous pond upgrades wouldn't be going to waste. They would still be utilized for ammonia polishing. And I actually showed the results of this study in last week's webinar, but the BioCord pilot system in this location, with the BioCord pilot system in this location, we were able to demonstrate very consistent BOD removals, as well as achieve the enhanced cold weather ammonia reductions that we wanted to see. So for the full-scale design at this facility, we have some reactors in pond 2 to fully bring down the BOD and alleviate the load into pond 3. So that the upgrades that were implemented here, as I said, can be dedicated solely to ammonia removal and aren't just wasted for BOD. And then in the full scale design, we also have some reactors on the front end of pond 3 just to help maintain and enhance that ammonia treatment in cold weather conditions. And overall, the size of the full scale system that we designed was actually much smaller and had a lower capital cost than it would have had if we had designed it based solely on the original data that was provided to us. Since from that data, we were able to maximize the treatment for the existing process first, and then design our BioCord system as a supplemental enhancement to ensure that the facility could consistently meet their targets. So in general, you can install your BioCord system or BioCord pilot unit at different points in the existing process flow. And the best place to put it will depend on a number of things. The first one being your actual treatment targets. So what the contaminant of concern that you're actually looking to reduce is, of course. And this is just a general guideline to point you in the right direction, which essentially states that you should install or test your BioCord in the location that has the highest amount of the target contaminant, but the lowest amount of inhibiting substances such as TSS. So if your target is ammonia, that would mean focusing in an area with the highest ammonia concentration and lowest BOD. And that's because for your BioCord or biofilm to remain robust and for the wastewater treating microorganisms to maintain their activity, they need to be supplied with a consistent supply of food, which is why you want to aim for a location where your contaminant concentrations won't drop below around 5 milligrams per liter for prolonged periods of time. It's just going to be more efficient that way, and it will help ensure that BioCord is as robust as possible. And lastly, it might not always be possible, but if you can, try to avoid areas that see very large fluctuations in contaminant concentrations or locations that can run dry or have minimal flow passing through it, because you could starve out your system and it'll just make it a little bit more difficult to maintain consistency. We have to consider existing site constraints as well. So of course, sometimes there are physical limitations that prevent us from installing in a certain location. And I think this goes without saying, but if you don't have space in a specific area for a full-scale system, then you shouldn't conduct your pilot in that location because the results aren't going to be representative. So install the pilot where you're planning to install the full-scale system. I said in the previous slide that you should aim for a location with the highest target contaminant concentration and lowest concentration of substances that may be detrimental to BioCord. So high TSS or suspended solids is probably the biggest detriment to a biofilm or to biological activity because it reduces the surface area that's available on the BioCord for microbes to grow, and it also reduces the diffusion of substrates into the biofilm. So if possible, the TSS needs to be minimized either by locating the installation in a place with low TSS or by implementing a pre-treatment step, which in the case of a pilot system could be as easy as just removing the BioCord from the first tank and allowing that tank to act as a settling tank. Influent toxicity can also reduce performance efficiency of any treatment system. It's typically not an issue, but it's why I almost never recommend a BioCord pilot to be installed right at the front end, where any toxicity is going to be the most evident and the most impactful. If your facility receives industrial discharge, this could be more of a common occurrence. And I would look into your BOD-COD ratios for clues on the biodegradability of your raw wastewater. So a low BOD-COD ratio would indicate a higher presence of components that can't be treated biologically. And so I would avoid trying to trial a biological system like BioCord, where the BOD-COD ratio is under around 0.1 or 0.2 to 0.1, I would say, actually. So now that we've identified where we want our pilot and how we want to operate it, how do we decide what parameters we need to be monitoring for and how frequently should we be doing it? Of course, it's different for every pilot project, but what parameters you want to test for will depend on, of course, what your treatment targets are, the type of wastewater or what application it is, as well as potential for toxicity. So for example, if we're treating mine wastewater, we may want to monitor for things like heavy metals or other inhibitors, whereas with typical municipal wastewater, that's usually not an issue and not something we would regularly monitor for. We also want to think long-term about what data is going to be useful to us in the future. For example, like I mentioned, the BOD-COD ratio can help measure toxicity levels in your raw wastewater. So even if your treatment target is only ammonia or something else, if you're sampling anyway, you might want to include some contingency for BOD-COD, just so you have a baseline of what's coming into your plant that you can use in the future as an indicator of industrial spills or toxicity in your system. How frequently you want to sample will depend again on your targets for treatment, whether or not your plant discharges continuously or intermittently. If it discharges continuously, it is recommended to also sample more frequently to ensure a stable effluent. If you have a longer pilot project overall, you can get away with sampling less frequently, although daily sampling is still recommended during startup. Your budget is also another consideration. And lastly, if the facility in question is prone to highly variable flows and loads, or quick changes in conditions like temperature or pH, it's definitely a good idea to sample more frequently to be able to capture that data and monitor performance throughout these changes. And of course, if you had a good historical data set to begin with, you can get away with sampling fewer parameters at lower frequencies. So this is just an example of a sampling and analysis program that we recommended for a pilot targeting ammonia in cold weather. In this case, the facility had some historical data, but it was really only valid for certain conditions. So upon startup, or for the first 2 weeks of pilot operation, when our BioCord system is first developing into biofilm, we would recommend daily analysis of dissolved oxygen, pH, and water temperature at the influent and effluent to our system. So these three parameters here are hugely influential on biological activity. So it's really important to make sure that they're all within an appropriate range, especially as we're starting up our system, and it usually is. So these can be monitored fairly easily since most facilities will already have a pH or a DO probe that can be used every day. If they don't, we can provide that for you. So these should definitely be recorded daily. Of course, since ammonia was a treatment target, we want to be analyzing that to monitor the progress of our system. And since, as I said, organic content is another parameter that influences nitrification, we also want to keep an eye on that COD number. So for the first week of daily testing, you can do it in-house instead of sending it off to an external lab, since the purpose is just really to ensure that all these parameters are within a good range to allow for BioCord to develop as intended and to track its progression and development. And that's also why we have COD here instead of BOD. You can do daily BOD testing too, but COD is typically faster and less expensive to analyze. So for the purposes of startup, COD is sufficient. And then we would recommend testing for BOD, TSS, nitrite, and nitrate on a biweekly basis. And this is to help with troubleshooting if needed. So after 2 weeks, the BioCord system won't have reached steady state quite yet, but you will start to see more significant reductions in ammonia. And by now we'll have a good idea of the COD levels coming in, so we can scale that back down. And then, yeah, so we can start monitoring that less frequently, more like once or twice a week, along with TSS, nitrate, and nitrate. Yeah. I would also recommend testing more frequently to start, especially if you have limited historical data. And then as results roll in and you find that the influent parameters are pretty consistent, you can start to scale back testing the daily parameters to maybe every other day, or these parameters maybe once every 2 weeks. So collecting samples can sometimes be a challenge, especially if there's limited availability in manpower. In this case, we do have ways to get around this and still obtain the data that we need. One option is automated samplers, which can take wastewater samples from the influent or the effluent and preserve them for analysis later on. So you can set them to collect a sample and then have an operator just come in every week or every 2 weeks to grab the samples, send them in for analysis, and then reset the cartridges for the next set of data. We also have the capability to integrate some real-time monitoring and data logging into our pilot systems. By installing probes that can continuously monitor and log levels of contaminants like ammonia or parameters like dissolved oxygen. That's a great option if you have very limited historical data, because it really just gives you so much insight into what's happening into your system by giving you hourly or half-hourly updates about what's going on and what's going in and going out. Lastly, we can also use sensors for process control. Roberta is speaking more about this in our webinar 2 weeks from now, but I will mention that we can use probes to automatically adjust things like the aeration or alkalinity dosing if it's required, just to ensure that your DO or pH is always maintained in that proper range for optimal treatment and that you're not concerned about these fluctuating values in your system. So now that we've installed and conducted a pilot and collected our data, how do you make the transition from pilot testing to full scale? A lot of our clients have the question about scalability factors and how we ensure that the great results we saw during piloting will be replicable in the full scale. So we take into account a number of different things, but whether you're piloting with us or with someone else, these are all good scale factors to keep in mind. So as it relates to the size of our system and how many BioCord reactor units we need, of course, we look at the flow rates and volumes. So how much flow we treated during piloting versus what the full plant flow is will influence how many more reactors we need to add. But more importantly than that, we also want to look at the contaminant loads. So how many kilograms per day of ammonia or BOD was our pilot unit able to remove versus how many kilograms per day will be coming in from the influent. We also look at a design factor called surface area loading rate and surface area removal rate, or SALR and SARR values, to determine the scale factor for how much surface area we want to provide in the full scale system. So we obtain these numbers from piloting, although we do have standard values that we like to use. And this basically tells us how many grams or kilograms of a contaminant our BioCord system can remove per square meter of surface area that's provided. And Roberta will be covering more details on that in next week's webinar. Our full-scale sizes may be also a bit bigger than the pilot units, depending on the pond or basin dimensions, if it's an in-situ installation. And we also look at the oxygen demand to make sure BioCord's integrated aeration system is robust enough to be providing enough oxygen to fully remove the incoming full-scale and contaminant loads. And finally, Roberta will be speaking about this next week as well, but I do want to mention that we can also use third-party wastewater modeling software to run simulations of our full-scale design. So that will just help us verify that the process is able to achieve the effluent targets for ammonia or BOD or whatever the targets are. Or it will tell us maybe if we need to add 1 or 2 more reactors to the design to make it a bit more conservative to handle the fluctuations, that sort of thing. And it also helps provide some additional confidence that our system is designed as best it can be. We also consider the configuration of the BioCord system. Since the pilot unit is containerized, we do design our full-scale systems with that in mind. So we always ensure that the hydraulic retention time or the contact time between the wastewater and the actual biofilm is maintained in the transition from piloting to full scale. And when we pilot, we set the flow rate knowing that we will have to do this. So we look at the numbers and the full scale flows to make sure that we're not being too conservative with our pilot flow rates or HRTs. We can achieve this contact time and minimize short circuiting by using baffle curtains or other similar barriers to direct flow through our BioCord reactors as shown here. And we can also consider environmental factors such as pond freeze-over or wildlife that may be different in an open system versus a containerized system. And we can configure systems to mitigate against these challenges by providing things like bubble curtains around our systems to ensure that the water remains open in the wintertime and to dissuade wildlife from getting too close. So to finally reiterate some of the main points from this webinar, pilot projects can be extremely advantageous, but there are a lot of things to take into consideration when implementing one. So whether you're piloting with us or with someone else, you should always have these things on the forefront of your mind and ensure that whoever you're piloting with is putting the same time and thought into these considerations, or else you may find that you're putting a lot of time and money into something that ultimately won't have substantial value to you. So with Bishop Water Technologies, we can design pilot programs to your site-specific wastewater characteristics. We consider the client's budget, timeline, and target treatment goals to develop the best pilot program suited to their needs. We provide ongoing support and data interpretation during piloting to ensure the system is working as intended, is operating at its best efficiency, and is achieving the best reductions possible. We also always consider scalability factors to ensure that the results obtained are representative of what can be expected in full scale. And a comprehensive pilot report is always provided to the client after every project to clearly show performance results and present the data in an easily digestible way. As well, we also ensure that there's value gained from piloting, whether it's by meeting your pilot objectives and transitioning to full scale, or by providing you with important insights into your existing facilities processes and creating a usable data set that can help save you money in the future. And our last point here is to remind you that Bishop's pilot project's costs can be credited towards the purchase of a full-scale system. And so that's almost it for this presentation. I have the last few slides just going over who we are as a company, as well as some of our keystone technologies. What I'd like to highlight about Bishop Water is our technology focus as a company. Over the past 20 years, we've dedicated a great deal of effort into developing technologies and systems that provide economic and environmental benefits to our clients and their communities. We have a number of different solutions that can be used separately or in tandem to address a whole array of wastewater treatment solutions or challenges. I mentioned Bishop Water's solids management solution briefly before in a previous webinar. These geotextile containers can be used not only for sludge and solids dewatering, but they can also be used for shoreline protection and the prevention of shoreline erosion, as well as in permanent process facilities. Our BioCord reactors, as I've covered in these webinars, are great for biological nutrient removal and enhanced cold weather treatment. We also have a range of other products that can help augment treatment. So beneficial bacteria can be used to help with bioaugmentation. So these are essentially different kinds of blends of wastewater treating bacteria that you can add to your system to help inoculate it or give it a little bit of a boost if you're struggling to maintain a population of a certain type of bacteria like nitrophires or heterotrophs. And lastly, we offer a rare earth coagulant for phosphorus removal called RE300. This is essentially a more effective, more versatile, and less hazardous alternative to chemical coagulants like alum or ferric that is used to precipitate out phosphorus at only a 1-to-1 molar dosage ratio. So RE300 can be used easily to help achieve really stringent phosphorus limits. And we will actually be putting on an RE300 webinar in mid-July. Where we'll go into more details on RE300 and how it works. So follow our Twitter or LinkedIn if you would like to stay updated on this new innovative coagulant. And that's essentially it. As I mentioned, we'll be setting out some literature. If you have any questions or comments, please don't hesitate to contact Roberta or myself. We'd be happy to answer your questions about piloting or biocords in general. And yeah, that's it. Thanks very much for listening. And I will take some questions now if we have any. So the 40-foot box indicates a flow rate of up to 32 cubic meters per hour. Is a 20-feet box workable, and what approximate flow rate is possible with the same inflow BOD as a 40-feet container? Thanks. So yeah, so we do have a 40-foot container as well as a 20-foot container. I would say the flow rates are dependent on what kind of influent you're conducting and how big your tanks are inside, but it could also go up to 32 cubic meters per day. Your HRT will just be a little bit smaller. I would say if you have like 5,000 cubic meters of tankage, you would want to maintain at least a 6-hour HRT. So if that gives you an indication of what the flow is, let me know. I can also, if you email me, I can also send you a calculator for that. What are the biggest threats to BioCord system operation? E.g., when nutrient flow ceases, how long can it last with no nutrients before it fails completely and the biology dies? So that is dependent from system to system. Typically, if you lose flow or if you lose nutrient concentrations for like a few days or a few hours, that's not going to be an issue. When you turn the system on, your biology will develop in accordance to that. So you might experience a little bit of a slower startup after that shutdown period, but the biology isn't going to die off. We have found that BioCord reactors are quite resilient. So even if you don't have flow going through it, you will still be able to maintain treatment upon startup. It might just take a little bit longer to get there. So if it's been gone for, if you haven't had power to your system for a week, it might take maybe 3 or 4 weeks to get back to the reductions that you were seeing, or it could take less than a week. We've seen different scenarios. I would say if your power or if you're not getting flow for over a week, that's when you can start to see a little bit more detriment, not because of a lack of biology or biology die-off, but because it can allow for a vegetative overgrowth on your system. Like if your water is stagnant, which decreases the surface area and causes a little bit of clogging. So that would be the biggest detriment, I would say. And I think that's all the questions that we have for now. So if you have any more or if you'd like more information, please contact us. Our information is here on this slide. And once again, thanks so much for coming to our webinars, and I hope you register for the next two. They're going to be really interesting and informative. So thanks. Have a great afternoon, everyone.